In this question, they ask us, what property is illustrated by the expression, and I'll write it over here so you can see, 3x times 6y equals 6y times 3x. Okay, well, let's just notice what they did here. What are they doing and what did they say? Well, they're saying that this is equal to this, so things are equal. And what operation are we doing? Well, we're multiplying everything. So this has something to do with multiplication. And it also looks like to me that we started off with 3x times 6y, and then the order is different over here. We have 6y minus times 3x. So all we did was flip the order, right? 3x is moved last, and 6y was moved first. So it looks like we're multiplying. It looks like we changed the order, and it looks like even though we changed the order in which we're multiplying, things are still equal. That sounds like the commutative property to me. Remember, the commutative property, people often mispronounce it, right? They say the commutative property, and then pronunciation isn't always essential, but I think it's helpful here because if you look at the word commute, right? In commutative, the commuter, that's the person who's moving back and forth, right? So the commutative property tells us that A times B always equals B times A, or any variation of that. We can have 100 terms. It tells us when you're multiplying or adding, and if you're only multiplying or adding terms, you could easily and always swap the order of them without changing the result. And that's what we're doing here. So I would choose B. What about these other properties, though? What does all this stuff mean? Well, A says closure property of multiplication. Well, in order to show that, what that means is that you start, right? Let's say in some number set like the integers. All right, there's the fun symbol for integers. Well, you can test closure to see if you plug an integer or whatever number you're starting with into multiplication. That's our operation that they're focusing on. And no matter what order you choose your numbers, when you multiply them, you always get another type of that number. So in this case, if I had plugged in an integer, right, I could say that the integers are closed for multiplication because no matter what integers I put in to multiplication, I always get another integer, right, as a result. So this actually doesn't really apply here because I don't know, like, what are we really testing here for closure, right? I don't know. So I wouldn't pick that. The C choice says multiplicative identity element, which is one of my favorite numbers, the number 1. It's called the identity element of multiplication because this number 1 multiplied by any value and it doesn't change the identity of that number, right? 1 times anything is still that something. So that's why 1 is the identity element of multiplication. You can think, well, why is it not addition? Well, if you add a number to 1, you do change it. But there is an additive identity element, which you could probably guess what that is, right? And if you're struggling with that, just ask yourself, what can I add to something without changing its value? There's only one number that you can add and not change value. And that number is 0. So 0 is the additive identity because when you add, you don't change the value. 0 is not the multiplicative identity element because when you multiply anything by 0, you get 0. So 0 does change value of a number, but not addition. And D says the associative property of multiplication. So that's a close call, but that property says, and you might think that here because you see parentheses, but really all they're doing is switching order. If you're adding, right, 3 terms A plus B plus C, and you want to look at it in different ways, you can add A and B first in parentheses. You can associate them together, hence the name of the property, and then add C. But that's the same thing as A plus B plus C. Like in other words, here you do this first, B plus C. And that applies for addition and multiplication, right? We can group these in any way we want. But notice, we're not physically changing the order and location of them, just the way we group them or associate them. But that doesn't really apply here because, again, all we're doing is rearranging order. Okay, so I hope this helped.